So let's put it here. Rules. Let's put a little bit of rules. We say we start with knowns. What is your known here? You've got two knowns. Whether you want to start with the 20 degrees or you want to start with the 60 degrees, it's entirely up to you. We need to move. Start with knowns and move towards the unknown. Rule number 2. So rule number 1, you start with your knowns and you move towards your unknown. Now in real life, if you were on a journey and you wanted to start from Johannesburg going to Cape Town, you would need a vehicle. You can either go by bicycle, you can take a walk, you can take a train, you can take a plane. There are many ways to get to Cape Town. So you need a vehicle. And what is your vehicle in geometry? Your vehicle in geometry are your laws. Your vehicle in geometry are your theorems. So you use the theorems as your vehicle. So let's put it as your vehicle. So we start with the knowns, moving towards the unknowns. We use our theorems as a vehicle. Step number 3, we always we identify what's given. So let's put there, we identify what's given. So we identify the theorems even before we begin with our problem, because we will have a map. It maps it out for you. And then, obviously, now we all know to get from Johannesburg to Cape Town, there are many routes. So now you select a route, a shortest route. And that's it. It's a 4-step process. We're going to select the shortest route to get. Many ways to get from Johannesburg to Cape Town. We can take the garden route, the most beautiful scenery. You can take the scenic route, which will take you probably 3 to 5 days to get to Cape Town. You can go by train, which might take you 2 days. You can then choose your car. Many, many different routes. Whether you want to go through KwaZulu-Natal, whether you want to go through the Free State, entirely up to you. But obviously, we want to get to our destination in the shortest possible time. So we're going to choose, we're going to elect, or we're going to select the best, shortest possible route. So we're going to select the shortest route. So here we go. Let's get started. Let's attack. Let's identify. Now obviously I'm doing this just as an introduction. When we do our proceeding riders, I'm not going to go. We're just going to go directly into application. These are the mental processes that I will be using in order to attack that scenario. Now, we start with the knowns. We got a 20, we got a 60, we've got a 20. We need to move to our unknowns. Where's our unknowns? X, Y, Z. We use our theorems as a vehicle. Let's identify what's given. Let's see. We've got a diameter. So all our rules with regarding to a diameter will apply to this problem. There's no tangent here. As you can see, there isn't a tangent, no tangent. So all the rules with regard to our tangent will be left out. The only rule, we've got a diameter. What else do we have? We've got radii. Remember, radius. The plural of radius is radii, and we know that radii are equal in length. And the minute we have radii, what else do I have? I have a triangle. Two sides are equal. Hence, what does that imply? It implies that we have an isosceles triangle. Remember, this here now becomes an isosceles triangle, and that's going to help us, guys. It's going to help us. It's going to help us tremendously in getting to our solution. So let's get started. Let's start with the diameter. Identify what's given and let's select the shortest route. And what did I say? The minute you see a diameter, start including your 90 degrees. So if this is my diameter, we know that a diameter, according to our theorem, a diameter subtends a 90-degree angle at the circumference. So that must be 90. Although it's not given in the shape, you got to include it. And the minute you get an angle and you're confident that that angle is correct, go in and put it in the diagram, because that's going to help you to solve. So the first thing that I'm going to do, you could have started anywhere. This is just my method of doing it. I started with the diameter, I subtended a 90 degrees. I know there's a triangle here, so obviously I'm going to solve for y first. So we know the first thing I'm going to say, angle B, angle CBA. So CBA is how much? Is equal to 90 degrees. That's the first statement I am going to make. You could have started anywhere. Okay? There's no rigid rule as to the order in which your theorems or your reasoning must be given. As long as you can justify what you... That is why mathematics is so important. Because mathematics teaches you the skill not to just make a statement. The minute you make a statement, whether it's in real life, in a real life situation, you accuse someone in life, you call him a liar. The first thing the judge is going to ask you in court, why are you calling the man a liar? Give me a reason as to why. So the minute you make a statement, you've got to give a reason. So we made a statement, CBA is 90. What is the reason that you are saying that CBA is equal to 90? Because you can say angle in a semicircle. Or you can say a diameter subtends a 90 degrees at the circumference. So now you'll get a mark for that. That is worth 1 mark. Why? You've made a statement and you've justified it with a mathematical law. Not something that just came to your head. With a mathematical law. With a theorem as a justification. So we got CBA is equal to 90. Okay. So therefore, angle Y is equal to, if this is a triangle, 180 minus 180 minus 90 plus 20. 90 plus 20. 180 minus 90 plus 20 is 110. 180 minus 110 is 70 degrees. So we know that this is 70 degrees. Why did you say that it's 180 minus 90 plus 20? Because we know that sum of the angles of a triangle is equal to 180 degrees. That is why we use 180 minus the sum of these two angles. So now that we've got that to be 90, we've got 70, we've got 20. We now need to get x, we need to get d2, we don't need to get d2, and we need to get z. So let's go under C. This is an isosceles triangle, and how would you prove it? You would now say OD is equal to OC because they are radii. So OD is equal to OC, radii, therefore triangle ODC is isosceles. So if it is isosceles, therefore x is equal to 180, sum of angles of a triangle, minus your given, minus 60, divided by 2, because these two angles are equal. Isosceles triangle. Sum of angles of a triangle. Sum of angles of a triangle equal to 180. So what do we have? Angle x is equal to 180 minus 60, 120 divided by 2, 60 degrees. So x is equal to 60. So obviously, if this is 60, x is 60, d2 will also be 60. How much will z be? Z is equal to, what do we know? The exterior angle of a triangle is equal to the sum of the interior opposite. So exterior angle equal to the sum of the interior opposite. Angle Z is equal to 60 plus 60, which is equal to 120 degrees. Or you could have used adjacent supplementary. I think that would be the better one to use. Right, we're cutting now for an ad break, guys. Make sure that you've taken all of this down. Angle Z is equal to, let's use it this way, 180 minus 60, which is equal to 120 degrees. Adjacent supplementary, meaning sum of angles of a triangle add up to 180 degrees. Boys and girls, we're going for an ad break. When we get back, we're going to do more complex riders. Stay tuned.